So we're going to put everything together now that we've learned in this section 1.6, the limits involving infinity. And so we want to find vertical and horizontal asymptotes and then any holes. And I want to evaluate the given limits, okay? So the first thing that I'm going to do is I'm going to evaluate this limit as x approaches 5 of f of x. Now, when I do this, I'm going to plug in 5 and just see what happens. If I plug in 5 in the numerator, I get 0, okay? 5 here is 125, and then that's going to be 25 times 4 is 100, and then 5 there, I guess that's 155 maybe. If I do all that math out, I'm going to get 0 in the denominator. So what does this tell me? This 0 over 0 is telling me that there's some x minus 5 factor in here. Okay, so there's a theorem in college algebra that says if we plug in a number and we get out 0, okay, then that tells me that x minus that number is a factor. So that's where this x minus 5 factor is coming from. Now, I think it's the factor theorem, but I could be wrong on that one. All right. Anyway, so x equal to 5 tells me there's an x minus 5 factor. And so what I'm going to do is I'm going to do some long division. So I'm going to do some long division here. I'm going to divide and see if I can't figure this out. So how many times will x go into x cubed? If I multiply it by x squared, okay, then I get x cubed minus x to the square. And so what I'm going to do is I'm going to draw the line and then change the sign. And whenever I do that, whenever I subtract, the x cubes cancel. This minus a minus becomes a plus, so it becomes 9x squared here. And now the question is, what do I multiply this x by to get 9x squared? I think I can multiply it by 9x. Okay, so I'm going to bring down this negative 31, multiply by 9x. And if I multiply this by 9x, I get 9x squared minus 45x. Draw the line, change the sign. Whenever I draw the line, I subtract, these go away like they should. Negative and a negative make a positive. So positive 45 minus 31 gets me 14x. Bring down the negative 70. And what do I multiply x by to get 14x? Well, I multiply it by 14. And so I put the 14 up here. I do the 14, draw a line, change the sign, right? And so these cancel, and then these also cancel because the negative turns out to positive. So this is 0, so what does that tell me? That tells me that this right here is equal to this factor multiplied by this factor. Okay, that's what the factor theorem, whenever I do long polynomial division, this is one way to help me factor. And so I've factored this nasty thing into that right there. Okay? Awesome. So why is this awesome? Well, I think I can even factor this a little bit more. Okay? This is a trinomial, so I need something that multiplies to 14 and adds to 9. 2 times 7 is 14, and 2 plus 7 is 9. So this factors to x plus 2, x plus 7. So that factors away there. So that's going to even break it down even easier. So how about that? That was pretty nice. Now, what can I do here? I see that these two factors can cancel. Why can I cancel them? Well, guess what? I'm taking the limit as x goes to 5. Okay, and so there happens to be a hole at x equal to 5 because we can cancel those factors out like that. When I can cancel those factors out like that, that tells me right there I've got this hole going on at x equal to 5. Okay, And so this is equal to this rational function as long as x is not equal to 5, but if it's a whole, then we're not equal to 5 there. So what do I do to find vertical asymptotes? You think about it. You take the limit, okay? So typically, college algebra, we would just set the denominator equal to 0, and then we say that we can't have those values, so that would mean x can't be -2, and x can't be -7, right? Those are my vertical asymptotes. Now for calculus, excuse me, I'm going to want you to take limits. So you're going to do the limit as x goes to 2 from the right. I'm sorry, -2, because that's for that one. -2 from the right, and I plug in 1 over x plus 2, and then x plus 7. And if I plug this in, what do I get? I get 1 over, okay, something that's a little bit bigger than -2 makes that a -0. And then this one, a -2 and a 7 make 5. So that doesn't really do anything. So this is really 1 over a really small negative number, which is really negative big number. So that goes to -infinity, which then tells me that this is true. Okay, so that's the work that I'm looking for. I don't want you to just write out, oh, x equals -2 is a vertical asymptote, okay? So I want you to show me, you know, you either do a left-handed limit or a right-handed limit like I did here. I don't care. You just pick one and you go with it, okay? Because remember, to show that a vertical asymptote is true, I need to show that either a left-handed limit or a right-handed limit produces a plus or minus infinity. Okay, that's what I got to show. Okay, and then you can work through the same thing. You should practice this for x equal to -7, and hopefully you can get the answer too. Okay, so that covers our vertical asymptotes. Now, horizontal asymptotes. To find horizontal asymptotes, what do? To find a horizontal asymptote, I take a limit as x goes to infinity or x goes to -infinity. And if that equals some number, then y equal to that number is the horizontal asymptote. If it's infinity, then there is no horizontal asymptote, or -infinity, either way. Okay? So I'm going to take the limit as x goes to infinity, and I'm going to bring this down here. And so when I take the limit as x goes to infinity, what do I know? The numerator degree is 1, the denominator degree is 3. So I know bigger on bottom. Bobo means y equals 0, so I know that. I can use algebra. Degree 3 is the largest degree, so I multiply the reciprocal largest degree term. And so in the numerator, I have x times 1 over x cubed, and that gives me 1 over x squared. Okay, that's where that's coming from. And I have 1 over x cubed times -5, and that gives me that term right there. Here, multiply by -70, I get this term here. Multiply this by -3 over x squared, or x. Now I have an x in the denominator here, and I have an x cubed in the denominator there. Wait a second. What's going on here? Okay, I'm sorry. I read this wrong. That's not divide by divide by x. That's 31x. Sorry, that my 1 was a little off. So that's 31x multiplied by x cubed. Sorry about that. And so that'd be 31 over x squared, okay? Because you have x in the numerator, 3 x's in the denominator. Cancel one of those x's, okay? Then you'd have this multiplied by that there. 2 x's up top, 3 x's down low. 1 x survives in the denominator. And then the last one, x cubed times 1 over x cubed is just 1. And so what do we get? Basically, all of these terms here are going to limit to 0. Okay, it's a constant divided by something that's going to infinity, or infinity squared, or infinity cubed. Guess what? That's infinity. And so 1 over a really big number, all those things go to 0. And so when I do this, I end up getting 0 divided by 1, which still happens to be 0. So when I take the limit of this function here, I get 0. And so if I get a number, 0 is a real number, that tells me the horizontal asymptote is y equals 0. Now, Bobo, for college algebra students, they would have just said, oh, it's Bobo, therefore y equals 0 horizontal asymptote. That's pretty easy, right? So you kind of know what the answer is going to be, but I'm looking for this work here, so that's what I'll be looking for whenever I look at grading tests. Okay. Last one, limit as x goes to negative infinity. All right, see if we get something different. Typically we won't, but sometimes we might. So take my limit here as x goes to negative infinity. Now, as x goes to negative infinity, the only thing that changes here is, well, look, every term is still going to 0. Even if it's negative 0, it doesn't matter, right? That's still 0. But this term here, this was x cubed, right? So as x goes to infinity for x cubed, that's going to be positive infinity. But as x goes to negative infinity of x cubed, what's negative times a negative times a negative? That's actually a negative. Okay, so instead of having a positive 1, it becomes a negative 1 there. Okay, so that's the difference. All right, so that one right there will be a little bit different. Okay, if you're thinking about that for just, you know, more than 2 seconds, you see that limits to negative 1. But it doesn't matter, because what happens? I have 0 over a negative 1, which is still equal to 0. And what does this tell me? This tells me the horizontal asymptote is y equal to 0 there. Okay? Now, I kind of stressed this a little bit about the negative infinity versus the positive infinity. Typically, you know, we don't have to worry about it if the horizontal asymptote is, you know, y equal 5, then going to positive infinity. Typically, that's going to be the same case for negative. And what we'll see here is that it's not always the case, and I'm going to show you through this example right here. So say I have some function g of x. Okay, so g of x equals 3x, then square root x squared plus 1. Okay, try my best to write with my broken finger. So sorry if it looks a little sloppy. That's the reason I'm having to do the videos like this, because, you know, my finger's all messed up right now. Okay, so don't slam your finger in the door. That's no bueno. All right, now vertical asymptotes. I want to set the denominator equal to 0. Set the denominator equal to 0. Well, guess what? Square root x squared plus 1 equal to 0. If I square both sides, I get x squared plus 1 equals 0 squared, which is 0. Subtract 1, I get x squared equals negative 1. But when I square root this, I get x equals, well, square root of negative 1 plus or minus, that's I. Guess what? We're dealing with real numbers, not imaginary. This is not complex analysis. Therefore, there are no vertical asymptotes. Okay? So there's no vertical asymptotes. What about horizontal? Okay? Horizontal asymptotes, I take the limit as x goes to infinity of the function g of x. And so what does this look like? This is the limit as x goes to infinity of 3x over the square root of x squared plus 1. Okay? So if I take this limit, well, I've got a little bit of algebra to do. Okay, I got a little bit of algebra to do, because I have a square root in here and not a square root up there. What I'm going to do is I'm going to factor the x squared out of this denominator piece, and so I have a limit as x goes to infinity of 3x over, and I have x squared factored out of this, and so If I factor an x squared out of x squared, I just have 1. If I factor an x squared out of 1, what the heck do I have? Well, I got 1 over x squared, okay? So, little tricky. That's a very clever little trick, but this is a way to factor anything out of something. If I just, all you have to do to check to make sure you did it right is see if it multiplies back through. That's x squared, and then that's plus x squared over x squared, which happens to be x squared plus 1, which is what I wanted. So we're okay here. All right, there's nothing wrong with that, what I just did right there. Okay, so now I've got something that I'm going to positive infinity. Whenever I'm taking square roots, this thing is going to be positive. So look, I can break this up into square root of x squared and the square root of 1 plus 1 over x squared, okay? And guess what's happening? This piece right here behaves roughly like the absolute value of x. The square root of the square is basically x in absolute value, okay? So it's a little bit different, right? So basically, what is this equal to? This is equal to the limit as x goes to infinity of 3x over the absolute value of x times the square root of 1 plus 1 over x squared. Okay. Now, if x is going to positive infinity, what can I do? I can drop the absolute value because guess what? For x greater than or equal to 0, this is equal just to x, right? So clearly I'm greater than or equal to 0 if I'm going to infinity. So I have 3x over x and then square root 1 plus 1 over x squared. And the x's cancel. And so this gets me the limit as x goes to infinity of 3 over the square root of 1 plus 1 over x squared. All right? And now whenever I take the limit as x goes to infinity, this is the only part right here that is affected by my limit. So I have 3 over the square root of 1 plus, well, guess what? I do 1 over something really big squared, that's going to be 0. Okay, positive 0, which is 0. So this gets me 3 over square root of 1, which is 1, and so that equals 3. So that tells me that y equals 3 is a horizontal asymptote. That's one of them. Now, what about limit as x goes to negative infinity? Limit as x goes to negative infinity of my function. So let's think about this for a second. Okay, so we're okay, hopefully, from here to here, right? Now, if I'm going to negative infinity, this changes a little bit. How does it change? Well, let's think about it. Absolute value of x for negative numbers becomes negative x. So this becomes limit as x goes to negative infinity of 3x over negative x, okay? And then square root 1 plus 1 over x squared. Now, when I see here, x's cancel again, but I have a positive and a negative number, so the only difference is now instead of a positive 3, I'm going to have a negative 3. So I have the limit, I'm running out of room here, as x goes to negative infinity, right, of negative 3 over 1 plus 1 over x squared. Well, guess what? This denominator still works out the same way that does. The only difference is the numerator is negative 3. So y equals negative 3 is another horizontal asymptote. Okay, so we have two horizontal asymptotes here. And if you graph this function, it looks pretty weird, okay? So this is a hard problem. This is about as hard as it gets right here. So if you can do this one, you really have a deep understanding of what's going on here. So that's a good one to study. Make sure that you understand how to do it. Let's take a look at the graph of this function, see if we can graph it. Be interesting to see what that looks like. Let's take 3x divided by parentheses square root. I said x squared and then plus 1, I think. And then I'm going to close my parentheses here. Okay, enter. And now whenever I graph this, you can look. And you see when you go to the right, it looks like it's leveling off at 3. But when you go to the left, at x goes to negative infinity, it looks like the graph is having a horizontal asymptote around -3. So you see here, we have this situation where we're getting really close to -3 there, okay? And then whenever I take the limit as x goes to infinity, it looks like our graph is going to +3 over there, okay? So kind of a weird looking graph. You might not have seen anything like that before, but I just wanted you to see that it's possible to have more than one horizontal asymptote. That's why you don't think, oh, there's only one asymptote, don't have to worry about anything else. So be careful. Not only do you need to take the positive limit as x goes to positive infinity, but you also need to take the limit as x goes to negative infinity. Make sure that you see both cases, because this is an or statement going on right here. Okay, guys, hopefully this video was helpful, and shoot me an email if you've got any questions.